ever stop and wonder how, out of the trillions and trillions of bits of data flying around the globe at any given second, the exact web page you wanted just shows up on your screen? It feels like magic, right? But it's not. It's all thanks to this hidden set of rules, this secret language that computers use to talk to each other. And it all starts with a question you might not expect.
So what do you and your computer have in common? I know, it sounds like the start of a bad joke, but the answer is actually really simple. You both follow rules or protocols to communicate. And to get how your computer does it, we're going to start by looking at something we all do every single day without even batting an eye. Take a look at this. It's a super simple interaction. One person just wants to know what time it is. But think about it. Before they even ask the question, there's this unspoken script that they both follow. We all do it. It's a social protocol we learned so long ago we don't even remember learning it.
And that whole unspoken script? You can actually break it down into 4 pretty simple steps. First, you greet with a hi. Then, they acknowledge you with a hi back, which basically says, "Yep, I'm listening." Then you make your request. Got the time? And finally, you get the response. 2 o'clock. Simple, predictable, and it just works.
Okay, now here is where it gets really fascinating. When your computer wants to grab a web page from a server somewhere out on the internet, it follows almost the exact same pattern. It doesn't just bark and order for data, it has a polite little conversation first, just like us.
Yeah, this slide just lays it out perfectly. On the left, you've got our human chat. And on the right, that's your computer talking to a web server. Just look at the rhythm, the back and forth, the greeting, the acknowledgement, the request, and the response. It's the same dance, just with different words.
Let's actually map this out one-to-one. Our human hi is what's called a TCP connection request. TCP is just a set of rules that make sure the connection is solid. So it's basically your computer knocking on the door and asking, "Hey, you there? You ready to talk?" The hi back is the TCP connection reply. And your question, "Got the time?" Well, that becomes an HTTP GET message, a formal request for the web page. This predictable back and forth is, no joke, the foundation of the entire web.
So all of this brings us to the official name for these rules of engagement. In the world of networking, these scripts are called protocols. You can think of them as the official rules of the road for all the data zipping across the internet.
So what is a protocol, exactly? Well, according to the source material, it's pretty much the complete instruction manual for a digital conversation. It lays out what the messages have to look like, the exact order they have to be sent in, and what each computer is supposed to do when it sends or gets a message. It covers everything.
Okay, I get what you might be thinking. Isn't this all a little rigid? Why can't computers just, send data however they want? Well, the truth is, without these shared rules, the internet as we know it would just fall apart. It couldn't exist.
All right, enough with the theory. Let's get our hands dirty and actually dissect a real request that your browser sends out hundreds, maybe thousands of times a day. We're going to see a protocol in action.
The protocol we're going to look at is HTTP. That stands for Hypertext Transfer Protocol. And hypertext is just a fancy word for text that has links in it. The very thing that makes the web the web. This is the language your browser is speaking every single time you click a link. And this is what one of those requests actually looks like. See? It's not some crazy, complicated code. It's plain old text you can actually read. This is what's called an HTTP GET request. It's a simple, clear command telling a server to get a specific file.
What's so cool about this is how that simple text is broken down into a really formal structure. Every single HTTP request has the same anatomy: a request line that says what it wants, header lines that give a little more context, and sometimes a body with even more data.
Let's just zoom in on that first line, because it's the most important part. It has 3 distinct pieces. The method, which in this case is get, meaning I want to get something. Then there's the URL, which is the path to the thing you want. And finally, the version of the protocol you're speaking. Every single piece has a very specific job to do.
So, we've seen how HTTP works, but it's really important to get that HTTP is just one single player in this massive, interconnected ecosystem of rules that makes the entire internet tick.
I mean, just think about all the different things you do online. When you send an email, that uses a specific protocol. When you download a file, that's another one. A video call, you guessed it, that uses a whole different set of protocols. Every single thing you do online is governed by a specific set of rules designed for that exact task.
Here are just a few of the other big players on the field. You've got FTP for file transfers, SMTP for your email, and then there's DNS, the domain name system. That one's like the internet's phone book, turning human-readable names like google.com into the numbers computers understand. And each one uses a standard port number. You can think of that like a specific apartment number at a huge address, making sure the request goes to the right application on that computer.
So here's the bottom line. Protocols are the foundation. They're the shared language, the common ground that lets billions of different devices, made by thousands of different companies, all speak to each other perfectly. They are the invisible, absolutely essential agreements holding our entire digital world together.
And that really makes you wonder, doesn't it? If our entire digital world is built on these hidden rules of engagement, what other invisible protocols, social, cultural, you name it, are quietly running in the background, shaping the world around us every single day?
All right,